So if we use the fraction bar, we get what? Fraction bar 9 minus 18 over negative 18 minus 7. And the calculator tells you your answer is simplified out.
Oh, yeah.
Correct. So your slope was 9/25.
There you go.
Okay? And you just leave it like that.
Yo.
Just like it.
You guys are Puma.
What is the theme here?
Oh, cheetah.
Cheeto?
Animal Farm. It's Thursday.
Thursday.
Yes.
Okay, but what's tomorrow?
Not Thursday? No, we didn't plan that. I walked in, I saw it this morning. I'm
We're
like,
like, oh,
What's tomorrow?
no. Every Friday is Quarantine Wacky Rides. Every Friday. Every Friday.
Every Friday. Because you know why? One bar. That's why.
same thing here. As you get going, doing another one of your slopes, label it. First and second y values and x values. Slopes, change in y, change in x. 10 minus nothing. Negative 13 minus 18. So if you math that correctly, you would get what? 10 over negative 31, I believe. So your answer would have been negative 10 31s. It's kind of a fun slope. Okay. Excuse me. The next one you had, negative 18. They gave you some really nice numbers here. Okay. Start filling in your blanks for your formula stuff, besides staring at our cell phones. And then you have negative 12 minus negative 18. Not sure how to use the fraction or how to work with your negatives. Throw it into the calculator. It will do it for you. One of the things that students will do on one like this is that they'll forget that it's okay to have 1 in the numerator. So this becomes 1 over
4. 6. I didn't get 4. I don't know why I got 4.
All right. You go from there. Again, use the fraction bar to be all right. On 6, what do those two guys have in common?
6 negatives. They have it in common.
They had the x values in common, didn't they?
Yeah.
Remember what the rule was if your x values were in common? What was your slope? Wasn't 0. It was undefined. Remember, guys, when your slopes have the same value in the denominator, you get 0 in a denominator. That means that it has to be an undefined slope. Remember, your undefined slope is automatically when you have the same x value. That means it's a vertical line. If it's a vertical line, it has that undefined slope. Okay? If you notice that right away when you're doing it, you see you have the same x values, just write 0. Or sorry, 0 for the denominator. That means you have undefined slope. Okay? What's that? Yes, sir. Yeah, because the answer is not 0. Okay? The other graph ones, again, should have been really, really easy. As you start to learn to graph, you start at your y-intercept, which was 3, and it tells you have a slope of negative 1/4, which means your first step is to go what direction?
Down 1.
Down 1.
Down 1.
And then to the right.
4 to the right.
Down 4 to the right. The opposite of down and right is up and left. And there you go. 8, same idea, just go the other direction. You have a different slope. Starting at 1, up 1, right 3. Up and right, down and left. That one will look like that. We did 9 together, so you had to manipulate the equation. Then lastly, on number 10, what did you have to do there?
Number 10, you have to. Yeah, the graph, but we did it before we left.
Number 10. We grabbed them.
No, we did the problem before we left.
Oh, okay.
It was cool. The end of the problem was like,
What was your equation for 10?
it was like x plus 2 or,
X minus y.
Okay, then when you moved everything around,
and then when you moved everything, like x plus 2.
perfect, good. So when you move all this around, you get x plus 2 is y, which is the same thing as saying y equals x plus 2. So that should have been a really easy graph. All right. So today, what we're going to do is we're going to use these other examples that are here to walk ourselves through how do you write equations given specific information. Okay. Now, as you look at it, you've got ones where you'll notice that you have everything. We're always going to write our equation into slope-intercept when we're done. Sometimes we'll have to use point-slope form to get to that format. Sometimes we don't need it. So depending upon the information they give us is the amount of work that you're going to have to do. For example, this first one on number 11, it tells us you have a slope of 2 and a y-intercept of 4. If I have a slope and a y-intercept, am I going to use point-slope form or am I going to use slope-intercept form? Slope-intercept form, because it's already done for you, isn't it? So that means that your equation would just be y equals 2x plus 4. Because remember, the number in front of the x is always the slope, and the number here is always the y-intercept. Okay? Do you guys know why that the plus 4 is the y-intercept? Not just that. When you have a graph, as your graph goes through, like this, just for any graph, when it crosses the y-axis, what's the value for 0? What's the value for x at your y-axis? 0. So, I don't need to. So, what happens here is, as the value of x equals 0, if you substitute into that generic equation, what's 2 times 0?
0.
What's 0 plus 4? So that means that your y value has to be 4. Because when you guys first learned the graph, what you guys always did, you remember this, do you guys remember making tables?
Yeah.
Do you also remember when you did linear stuff? The numbers, you always... Exactly. Do you know why you use -2, -1, 0, 1, and 2? Do you know why you guys use those numbers all the time?
Why?
Well, these are the values of x that you're choosing to substitute into your equation.
Oh yeah, I remember that.
Okay? Well, the reason why we're using those numbers, well, 2 reasons. One, they're really easy numbers to use. And secondly, it shows you what's happening on either side of the y-axis. And it tells you where your y-intercept is. Because whenever x is 0, that's always where your graph runs into the y-axis. That's also going to come into play when you guys get into Algebra 2, when you deal with, or you guys did this last year with quadratics. You guys remember ax squared plus bx plus c? Does that vaguely ring a bell? When you had that, if you had x squared plus, 5x plus 6. If you had that, when you graphed it, you guys remember how you graphed that as a parabola and you figure out all that other junk and everything? Now, you also did tables. If x is 0, what's 0 squared? 0. What's 5 times 0? 0. What's 0 plus 0 plus 6? 6. So that means that this graph crossed the y-axis at 6. The y-intercept is when x is 0. That happens all the time. It's one of the easiest points to find. That's why we know that no matter what, this constant here is always the y-intercept. That's where that comes from.
That's easy.
Hopefully. So what would your equation look like then for number 12? If you have a slope of slope of -3 and a y-intercept, y equals -3x. Do you have to put the plus 0 in there? Or could you put -0 in there? Doesn't matter. It's just, you're just wasting ink. Okay. Now I know this one's not on there, but what if your slope is 0 and your y-intercept is -3? What if your slope is 0 and your y-intercept is -3? What would that look like? Louder. Exactly. Y equals -3. Again, if you throw those values in there, if you know your slope is 0, if you're not sure what it would do, gentlemen, 0 times x minus 3. What's 0 times x? 0. What's 0 minus 3? -3. What kind of lines have slopes of 0? We did this yesterday.
Is it the oh, wait.
Horizontal. Horizontal lines have slopes of 0. What's the second letter in the word horizontal? Oh, correct. The equation of every horizontal line is always the same. Y equals a number. Okay. Now, if you have an undefined slope, that means it has to go through an x value. And that's where this goes. We'll worry about that when we get there. Okay. Now, the other ones, as you get into it, are what we call literal equations. I think we had the example before of what we called a literal equation as distance equals rate times time. That's an equation we've all seen. I think you guys have all used it before. Okay? Psst. How's your phone doing? I don't care. Put it away. Thank you. You'll do better in class. Doesn't matter. Just still put it away. Thanks. You can tell your mom I said so.
Oh, sorry, you got the piece of paper.
And guys, just so you know, at the college, even at college where I use 60s, if you were on your phone during class, the teachers, they don't care that you paid $400 for the class. They don't care that you're supposed to get your mind and stuff for the next class. They will say, have yourself a good one. Just go. You're done. And so whatever we're doing today, you have 0. That means it affects your grading after you take the class, and hey, college loves that.
They love it when you have to take something.
More money from you to take the same class.
See, that's
On
Now-
the job, you'd be fired,
Yeah.
right? So there are those things too.
It's one of those things, guys. You have to start making better choices on some of this stuff. When you get into stuff like this, when you guys have all worked with this before, when we deal with what we call a literal equation, means we're trying to solve for one specific variable. If I wanted to get rate by itself, how would you undo multiplying by time? You would divide it, okay? You would have to divide out by time just to get it by itself. So distance divided by time would have been equal to your rate, okay? That's stuff that you guys have done. You did it in the science class at some point in your lives. Now, what's different with this is that, or really the only thing that's different is that you're trying to isolate y. So in this first one, you have 5x minus 4y is 16. And you want to get y by itself. Now, whenever you're trying to get y by itself, the first thing I want you guys to think of, first thing I want you guys to ask yourself is y positive or negative? It's negative in this case. If the y value is negative, I'm going to move it first, okay? And there's a reason why we do that, and I'll explain that here in a second. How do I move that negative 4y?
So the negative 4y, then you have to add it on the other side.
Correct. I'm going to add that 4y over going the other way. So I add the 4y coming over here. Have a great day.
Getting Kellogg Frosted Flakes.
And I get that. Are we okay with that? Is it okay if I put the y value in front of the 4y in front of the 16? Or does it have to go behind it? It doesn't matter. It doesn't matter. The order in which you add stuff never matters. 2 plus 3 is the same thing as 3 plus 2. Now, I have a y value that's positive. I'm going to move everything away from it. How do I move the 16? Subtract the factor. So then, just like we have been doing with our equations, here we can't combine them because one has a variable, one does not. So you get 5x minus 16 is 4y. Which lastly means, what do you have to do? Divide everything by 4. Now, you're right by saying dividing both sides by 4. What I want you guys to remember to do, though, is divide, I think somebody said it over here, divide everything by 4. By writing out that divide by 4 underneath both of those other values, you won't forget to do it to one of them by mistake. So you have 5x over 4. That can't be simplified. Okay, your fraction bar, use that in the fraction bar, it'll just spit that right back out at you. Remember, we don't use decimals. Okay, so this becomes 5x over 4. What's negative 16 divided by 4 then? Negative 4. And that equals y. Can I leave the y value on the right, or can I rewrite it to the left? You can leave it there or put it on the other side, it doesn't matter. 2 equals y equals 2 means the exact same thing.
You're really good at math.
You said a little bit, you didn't define it.
They're all the way.
Mr. Murphy.
You're welcome. I wouldn't be me if I didn't do that, you know that. Shoot and ask. Now, yes, sir. Now, some of you guys were wondering, the reason why I get rid of the y value first when it's negative is if you take your 5x minus 4y and you start moving the 5x first, what would you have done? How do you move the 5x to the other side? You'd have to subtract it, right? So, over the course of doing this job for a long time, most students would get to this and say, oh, it's negative 5x plus 16. A lot of times when people rewrite this, oops, first of all, I can't make the number 4. Yeah. More often than not, people will forget to rewrite the negative. That's why I don't do it this way. If I move this first, I'm alleviating the probability of this mix-up. Okay? So if you still do it this way, it's fine, it's no big deal. I'm always going to ask you guys the question at the beginning of any time we have to move equations around to get y by itself. Is y positive? If y is positive, I'll leave it where it's at. If y is negative, the first thing I'm going to do is always move it. And then I do everything else. Okay? You will be less likely to screw something up when you have a positive value of y to start to work with. Does that make sense? It's just one of those little tip things that I've always done, and I think it works pretty well. Okay. Let's look at the next one. The next one was 2x plus y is negative 1. Well, this one's really, really easy, isn't it? What's the only thing you have to do here? Right, the only thing we have to do here is subtract the 2x. So I get y is negative 2x minus 1. And I'm done.
No problem. Tell it all. He said, "Aw."
Log base x equals 1. No.
Log base x equals 1 second, right? Is it 1 or is it 0? It's 0. X equals 0.
See, put me in free cop already.
Which, yeah, never mind. What format does that look like? What form? Which form was that, guys? It's point slope, yeah. That's what point slope would look like when you substitute in. And we've done that also. What do you do from here to get y by itself? I know we did one real quick yesterday. What do we have to do to get y by itself then? What's that? Perfect. We got to distribute. Okay? So when you distribute, I want you guys to remember to draw your arrows so you don't forget to distribute to the second term because, gee, guess what most people do? They forget that second term. So we rewrite, we have y minus 1 is negative 1/2 x. What's half of 2? And then a negative times a positive is? Negative. Negative, very good. And then lastly, what do you have to move then? Add the 1, very good. Good. So your equation would be y equals negative 1/2 x. Well, it shouldn't be tough. Okay? It shouldn't be tough. So what's different between that one and number 16? It's just bigger numbers, really. There's no difference between it whatsoever. What's that? Yeah, there's no fraction there, but again, a lot of times with those fractions though, you're going to get, if they give you a halvesy, it's going to be half of an even number. If they give you a third, usually it's a third of like something that has a multiple of 3. It's stuff that you should be able to figure out. If not, you have a calculator. I hope. So let's see, on 16 it's what? Y minus 5 is, okay. So once you get that set written up, well actually you already have it written up, sorry. First thing to do then is just distribute. What's up?
Distribute the negative 10.
Good.
X and negative 4.
So you distribute to both parts. When we do that, we get negative 10x.
10x and positive 40.
Good.
And then don't you add 5 to the other side to make y by itself?
Yes. And what is your final result then?
Oh, you want me to do it? If
Sure, you got it.
No, put me on the spot.
Wait a minute, it's 4 fast.
Oh, 45. Oh, I thought you wanted me to do the whole problem.
You just did.
Oh,
Are you even paying attention to what you're saying?
nah, I kind of just blurted out what I think it is. But I'm getting it right.
That's the scary thing. All right. No big deal. No big deal.
Oh.
What's different now in 17? Isn't there points here?
No, it's 17.
Isn't this point slope form?
Yeah.
But it's point slope form given to you. The next one is you're given the point and the slope. Oh, well, it's easy.
So now you're making fun of
So as you get into this, it's giving you the point and the slope. What we have to do.
I don't know what I did.
I don't either, but it's always funny when she starts laughing. What I'm going to suggest that you guys do, write out the generic formula again, like we have been. Point slope form, y minus y sub 1 is your slope. Okay. Label your parts so you know what goes where. This is your x sub 1, your y sub 1, and there's obviously your slope. Fill in the blanks. Okay. So when you have y minus y sub 1, well, our y sub 1 here is 1. So we get y minus 1, slope of -3, and then it's x. Instead of writing minus and negative, what should we always write that as? A plus, okay? Whenever you have a minus, a negative, you always change it to plus, because minus and negative is plus, okay? And now you're at a problem that looks identical to the two we just did. All you had to do was get it to that format, which means distribute. So we have negative 3x minus 6 minus a negative. Whenever you have minus and negative, it always becomes a positive. Okay. And then lastly, I add the 1 over. What's that? Remember, if it's x minus a negative 2, whenever it's minus a negative, it's plus. Okay. And then add your 1 coming back, and your final result, 3x minus 5. Okay. Take a second and try 18. You've got a point and a slope. 18, you have a point and a slope. You have a point and a slope. Gentlemen, come on.
Okay, so
But guess what? This is math. You would have a tough time doing math. Shut it down.
So remember, always write out your formula first. Write out your formula, fill in the blanks, okay? So instead of writing y minus a negative 2, you would write y plus 2 is 7/4. Instead of x minus a negative 4, we write it as x plus 4. And now we distribute. So let's see, we have y plus 2 is 7/4 x plus 7. Very good. And then you subtract the 2 over. And like we said, it's y equals 7/4 x plus 5. Okay.
that's fine.
Final answer. We always write our answers into slope-intercept form. Now here, this last 2 then are the combination of everything. The last 2 talk about you have 2 points. So when you have 2 points, to write the equation into slope-intercept, Well, what's the thing you have to get when you have 2 points? Slope. After you have slope, then you can use point slope. So you have to do 2 things to make that one work. Okay. So the first thing you're always going to do is find your slope. So let's see, we have -5, -2. And the other one is at 1, 2. First thing we have to find is our slope. Okay. Like we did earlier today. You guys have the formula for slope. Fill in the blanks. Okay. 2 minus -2. 1 minus -5. Well, 2 minus -2 is the same thing as saying 2 plus 2. So the numerator becomes 4. 1 minus -5 is the same thing as saying 1 plus 5. So you get 6. Now, if that's something you couldn't do or you didn't remember how to do, put it in the fraction bar and a calculator, and it will do it for you. Okay? 4/6, simplifies to being 2/3. That gives me my slope, and now I have 2 points to choose from to use point slope for. Does it matter which one you use? No, it doesn't matter. Suggestion that I would do is that I would use the point that doesn't have or has the least amount of negative values in it, just because it's one thing that you'd be less likely to mess up. Okay. So if I'm looking at that, I would probably use the 1, 2. So I have y minus y sub 1, slope, x minus x sub 1. Here's my slope. Here's the point I'm going to use. So I have y minus 2 is 2/3 x minus 1. Again, what you wind up doing is distributing out like you have been. That doesn't change. 2/3 x. What's 2/3 times -1?
-2/3.
-2/3, yeah. Okay. Now, I have to add 2 to that. You have to know how to use your calculator. You don't know how to add fractions. -2/3. And then I'm going to add 2. And lo and behold, the calculator will do it for you. Okay? You should never worry about anything with fractions because you guys can use a calculator. So you add 2 coming back. And like you said, the answer was y equals 2/3 x plus 4/3. Okay. Yes, sir?
If you were graphing that and made it on a calculator and do a decimal, would you still upward
That would not be a y-intercept if you're going up 4/3, would it? Now, if you had to graph this, 4/3 is how much?
0.6?
No. 4/3. 4/3. Just think of it. 4/3 is 1 more than 3/3. Is it 1/3 more than 3/3? So it's a smidge more than 1? Okay. So if it's a smidge more than 1, wouldn't that just be about here-ish? And then if I have to go up a slope of 2/3, I think is what it was, I can still go up 2/3, 1, 2/3. I can fudge the graph enough to be close-ish to get a visual representation of it. The worst stuff that I really ever have students graphing by hand has these corners. You know, you're in that realm. You can still walk the slopes without too much of a hassle. I wouldn't worry about it. Okay. More often than not, you have a calculator to get the equation. Graphing something with a 4/3 y-intercept, it's not bad. It's just kind of a pain. I give up. Dropping something on your foot. Breaking your leg. So, and this one here,
That's lovely.
All right, okay,
Last one before we run out of time here. Another one where we have to do our, write the equation line that goes to those 2 points. First thing you gotta do is find what?
You find the
Slope.
slope.
So your slope, change in y, 1 minus negative 2, 0 minus 2. So your slope gets you to be at negative 3/2. Okay? I know I'm kind of pushing through this.
I did opposite.
Now, that ordered pair at 0, 1. What's 0, 1 in relation to a graph? What's the 0, 1? What does that mean that is? Where is 0, 1 on the graph?
Oh.
Where is 0, 1 at on your graph? Isn't it the y-intercept? X value is 0, your y-intercept is 1. You didn't know that, it's no big deal. Again, you go back to your, if you're substituting in y minus 1 is negative 3/2 x minus 0. When you distribute, you still get, what's 3/2 times 0? It's still 0, isn't it? And then how do you move the 1? You add the 1. And like I said, if you have a 0 for an x, that means it is the y-intercept. The y value is your y-intercept, always. Okay. Let's see. Let me see which ones we're going to do here. Now, on this one, what I want you guys to do is 11 through 20. Okay? We did all the slope stuff yesterday. We just did an example of every one of those. We kind of mirrored the same way through. So you have examples of every problem in front of you. We'll knock those out for tonight, and then I think there's only one other last little bit in 3-7 we'll do tomorrow, and then we'll probably have a little bit of extra time in class to get that done tomorrow. So,
Big class session, guys.